Hello class, good day. For this week's topic in Analytical Chemistry Laboratory, we will be dealing with pH, pOH, and buffers. This is being presented by yours truly. I am Miss Lena Yvonne Huco, and together with me is Miss Christina Matiba. So just a few reminders before you start watching this video lecture. Make sure that you will take down notes all throughout the discussion. Next is you will need a scientific calculator for this topic. So basically, there will be computations, okay? So wala po tayong takas sa calculations here in this topic sa laboratory, okay? Next is listen attentively. Avoid unnecessary distractions. There may be topics here that somehow can be confusing. So that's the reason why you need to avoid your unnecessary distractions, okay? Then, give extra attention to information marked with the star. So, ma'am, what does it mean if I will be seeing a star, such as this one, in any topic on this lecture? Guys, it only means that if you will be seeing a star, it may or may not be a recall question in the board exam. I repeat, if you will be seeing a star and you are in this video lecture or in this PowerPoint, it means that that information can be a recall question in the board exams before. So, it may be the actual question itself or it may be a related topic in the board exam. Okay? So, again, here are our few reminders. Take down notes, of course, so that you may be able to remember it more profoundly later on once you will be reviewing the topic. You will be needing a scientific calculator because there will be computations, especially the logarithm option of your cycle. And then again, listen attentively, avoid unnecessary distractions, and of course, give extra attention to information marked with a star because again, if you will be seeing a star anywhere in the PowerPoint, it may be a recall question in the board exam. So, sobrang importante kapag nakakita tayo ng star in any topic in this lecture. So, here are our learning objectives. First is we will be briefly discuss the acid-base concepts and terminologies, although this might have been discussed already in the lecture, but we will just review it and give additional information regarding it. Okay, then next is be able to describe what is a conjugate acid and a conjugate base. Third objective for this topic is perform the proper computations for pH and related terms. So, ayun na nga po, yung medyo nakakatakot na part. As a student, di ba, kapag may computation, somehow parang natatakot na alang, hirap nito ma'am, ganun. But, guys, we will be helping you on how to properly compute the pH and mga related terminologies and computations. Just listen attentively. We will be giving you tips on how to deal with it. And also discuss buffer and its properties. So again, here are our learning objectives for today. Briefly discuss the acid-base concepts and terminologies. Be able to describe what is a conjugate acid and a conjugate base. Third is perform the proper computations for pH and related terms. So I think this is actually one of our highlights in this topic. But I assure you that after this video lecture, you will know how to properly compute it based on the examples that will be given maya-maya. Then again, last, discuss buffer and its properties. So okay, let's start with the topic itself. So first is your acid-base concepts. Here in acid-base concepts, we actually have three theories. First is your Arrhenius theory. We also have your Bronsted-Lowry and the Lewis theory. All of these three are related. However, there is somehow a specific concept behind it. So first is the Arrhenius theory, wherein it is saying that an acid daw po yields a hydrogen ion in water. I repeat, Arrhenius theory, the acids daw based on this theory yields a hydrogen ion in water. I repeat, Arrhenius theory, with regards to acids, it says that it yields a hydrogen ion in water. Next, according to Arrhenius theory again, your bases yields a hydroxide or OH negative ion in water. I repeat, based on the Arrhenius theory for bases, it yields a hydroxide ion in water. Okay, so wag pagpapalitan ha. Again, according to Arrhenius theory, the acid yields a hydrogen ion in water, and your bases yields a hydroxide ion in water. This actually is somehow related, no, dun sa chemical formula ng ating mga acids and bases. If you can recall, in yung general chemistry nyo, ang chemical formula most of the time of our acids actually starts with hydrogen. For example, hydrochloric acid. If you can recall, the chemical formula for hydrochloric acid is HCl. And then, for bases, example of a base is sodium hydroxide, which is, ang chemical formula nun is NaOH. Diba? So, it is very related with regards to Arrhenius theory. Again, Arrhenius theory, it says that an acid yields a hydrogen ion in water and a base yields a hydroxide ion in water. Just think of the chemical formulas of the typical acids and bases. Diba? It is related with this theory. Okay, then another theory regarding acid and base is the Bronsted-Lowry theory. And I'll just, guys, want to recall what is a proton and what is an electron. So again, just a brief review. This is, for example, your atom. Okay, so your atom consists of many different parts, one of which is an electron, a proton, and a neutron. Wherein the proton, which is a positively charged na molecule, and then your neutron is neutral, kaya nga po ang tawag sa kanya is neutron, and your electron is negatively charged. I repeat, your protons is positively charged, starts nga po with the letter P, parehas sila, proton, positive. Neutron is neutral. Electron is negatively charged. Okay? So, ayan. This is yung atom. Just a brief recall. And what is a proton, electron, and a neutron? Because it is related po in Bronsted-Lowry and Lewis theory. Wherein the Bronsted-Lowry theory, it says that an acid is a proton donor. Proton, again, that is positively charged. And the Bronsted-Lowry theory, base is a proton acceptor. So again guys ha, huwag pagpapalitin. According again to the Bronsted-Lowry theory, an acid is a proton donor. Isipin na lang natin, ang mga acid kasi may hydrogen. Ang hydrogen is positively charged. So since meron siyang positive, kaya niya ngayong mag-donate ng proton, which is again a positively charged molecule. Okay? Positively charged part of an atom. Yun pala. Okay po. Then kay proton acceptor, isipin na lang natin na kapag ang mga base natin is, di ba, negatively charged siya. So, it can accept a proton which is positively charged. So, again, according to the Bronsted-Lowry theory, an acid is a proton donor, a base is a proton acceptor. Next, Lewis theory. According to the Lewis theory, an acid is an electron pair acceptor. And then, your basis is an electron pair donor. I repeat, according to the Lewis theory of acid-base concept, an acid is an electron pair acceptor and the base is an electron pair donor. Please do remember this table. Next, conjugate acid-base pairs. So, this is somehow different. A conjugate base is different actually from a base. And a conjugate acid is actually different as well from a specific acid. Okay, so a conjugate base, guys, ang kanyang definition, it remains when a proton is removed from a Bronsted-Lowry acid. Okay, and then a conjugate acid is formed when a proton is accepted by a Bronsted-Lowry base. So, for example, you will be needing actually a chemical equation to identify what is an acid-base pair or conjugate acid-base pair. So, for example, you will be having here, this is a Bronsted-Lowry acid. And then again, a Bronsted-Lowry acid, if you can recall, is a proton donor. So, once this Bronsted-Lowry acid donated its proton, and then in the other side of the equation, you will now have a conjugate base. I repeat, from a Bronsted-Lowry acid, Pagpunta niya sa kabilang side ng ating chemical equation, this will now yield a conjugate base. So again, a conjugate base remains when proton is removed daw from Bronsted-Lowry acid. So basically, kung nakikita here in this slide, from here, di ba, color yellow plus itong hydrogen, or sige, sabihin na lang natin, this is a proton. Once your Bronsted-Lowry acid donated its positively charged or the proton, pagpunta niya sa kabilang side, it is now already a conjugate base. Because again, acid na-remove, pagpunta sa kabila, conjugate base na siya. Okay? Kasi nawala na yung kanyang proton. Okay? So that is a conjugate base. Next, a conjugate acid. A conjugate acid is formed when proton is accepted by a Bronsted-Lowry base. For example, this is your base represented by this color green. From here, in this side of the equation, once it reached the other side, it accepted a proton. Therefore, this one, from the typical just green, it accepted a proton. This is now your conjugate acid. So that is your conjugate acid base pairs. And just like the animation in our lower right side, ayan, balik lang natin sa umpisa. Ayan, ito yung umpisa niya. So this is an acid. Merong positively charged dyan. It donated the positively charged particle, and therefore yielding this one. So that is a conjugate base and conjugate acid. Next, acid-base strength. So our acid or bases, we can actually categorize it if it's actually a strong or a weak one. If we will be saying that an acid or a base is strong is that it means it is completely or almost completely dissociates with water. So in the presence of water, the molecules of our acid or strong base completely dissociate. So basically, naghihiwalay siya entirely. And then your strong acids produces a hydronium ion or hydrogen ions. And then your strong base produces hydroxide ions as well. But it is very important, guys, aside from knowing what it produces, is that a strong acid or base completely or almost completely dissociates or naghihiwalay in water. So isipin na lang natin, kapag strong ka, pag naghiwalay kayo ng boyfriend or girlfriend mo, complete yung dissociation mo sa kanya. So, lalayo ka talaga entirely. Walang strings attached. Ayan. Ayan yung mga definition daw ng strong, diba? Yung kahit naghiwalay is talagang wala siyang pake, iwan na kita dyan. So, yun po ang relation ng strong acid and strong base. Okay? And then, what about yung mga weak? Yung mga weak na acid or bases. Kapag weak daw ang isang acid or base, it only partially dissociates with water. Just related with real life. So, yung mga weak naman sa love life, for example, kapag weak sila, kapag nakipaghiwalay, partial lang yung kaya nilang ihiwalay sa sarili nila. There is somehow still an association with that person. Diba? So, para mas madali nating isipin kung ano talagang nangyayari kapag strong ka daw, diba? Again, pag strong ang isang tao sa love life niya, kaya niya mag-dissociate completely with the other person. Like, maghiwalay na tayo, wala na akong paki sa'yo. Ganon. Kapag weak naman, weak kasi, mahal pa, ganon, partial lang yung dissociation. There are still strings attached dun sa tao. So, yan. Can be para mas madaling tandaan kung anong ibig sabihin ng strong or weak acid or base. And then, take note then that there is a term as ionization with regards to your strong acids or bases or weak acids and bases, wherein ionization is actually defined as a process in which individual positive and negative ions are produced from a molecular compound that is dissolved in a solution. Basically, guys, in layman's term, ang ionization po is yung paghihiwalay ng ions natin. Okay, so again, I repeat, pag sinabi po nating ionization, it just means that there is a parang paghihiwalay ng ating mga ions, ng acids or bases. So, for example, acid-base strength ionization. Di ba ang sabi, a strong acid or a strong base completely dissociates or ionizes. So, basically, a hydrochloric acid is an example of a strong acid. If you will be inputting a water molecule here, so HCl plus H2O, you will yield a hydrogen ion plus a chloride ion. So, ma'am, let's relate it nung sinabi na complete or almost completely dissociates with the presence of water. So, again, a strong acid such as your hydrochloric acid, once you will be inputting this with the water, you will yield a hydrogen ion plus a chloride ion. And pansinin, from here, HCl magkasama. Once it reach the other side of the equation, it completely dissociates. Parang nga nyo siyang hinati sa gitna, right? From HCl as a compound, nilagyan ng tubig, naghiwalay mismo yung hydrogen ion, this one, and yung chloride ion natin. So, this is an example of a strong acid, complete or almost complete ionization or dissociation. Next, a weak acid. A weak acid, for example, this CH3COOH is acetic acid. Acetic acid is a type of weak acid. Once you will be adding a water here, ang magiging parang product nyo nyan is CH3COO plus a hydrogen ion. And if you can try to check the chemical formula of your weak acid, if you will be comparing the dissociation with this, so dito kasi kay strong acid, di ba talagang naghiwalay siya sa gitna ng hydrogen, chloride. While a weak acid, nung nagkaroon ng dissociation or ionization, yung hydrogen ion lang yung humiwalay. So, tama tayo nung sinabi natin na ang isang substance is only weak na acid or base, it only partially, konti lang yung nag-dissociate or yung nag-ionize. Diba? Ito lang yung natanggal sa kanya, yung hydrogen ion only from the original chemical formula. And then, what about the strong base? A strong base is sodium hydroxide, for example, plus water. You will yield a sodium ion plus a hydroxide ion. And if you can try to check the chemical formula again, hinati yan sa gitna. There is a complete dissociation or ionization of the ions, which is yung Na plus OH, naghiwalay sila sa gitna. So, yun po ang strong base. What about a weak base, such as your ammonia? Ammonia plus water, naging ammonium plus a hydroxide. So, di ba parang hindi na nga siya naghati sa gitna eh. Nadagdagan pa yung hydrogen ion from ammonia, naging NH3 to NH4 plus a hydroxide ion. So, that is the definition of acid-base strength ionization. And then again, please take note what is a strong acid or base and what is a weak acid or base. And then, just to recall, the pH scale. Diba? Yung pH scale natin, I think we have from 0 to 14, wherein yung pH of 7 is considered as neutral, a pH of 0 or 1 to 6 is acidic, and the pH of 8 to 14 is considered alkaline. But, dagdagan pa natin ang kaalamanan natin doon. So, aside from that, guys, aside from ito, acid, neutral, or alkaline, meron pa po tayong tinatawag na strong, moderate, or weak. So, basically, dadagdagan lang naman natin. Yung alam natin na, ma'am, pag nakita kong pH 1 to 6 acidic, 7 is neutral, 8 to 14 is alkaline. So, magdadagdag lang tayo ng additional information regards it. At gagamitin nyo po ito sa post-laboratory na worksheets nyo. So, a pH range of 0 to 2 is considered a strong acid. I repeat, a pH range of 0 to 2 is a strong acid. A pH of 3 to 4 is a moderate acid. I repeat, a pH of 3 to 4 is a moderate acid. A pH of 5 to 6 is considered a weak acid. I repeat, a pH range of 5 to 6 is a weak acid. And then again, alam na to, a pH range of 7 is considered as neutral. Next, a pH of 8 to 9 is a weak base. Next, a pH of 10 to 11 is a moderate base. And a pH range of 12 to 14 is a strong base. So, ayan guys ha, pakikabisado po itong mga pH range na to. Alam kong alam nyo na yung acid, neutral, and alkaline. Just give additional information lang with regards to strong, moderate, weak, acid, or base. So, basically, by 2s lang naman yan ito. 2, 4, 6, diba? Ganun lang naman siya. Madali lang siya kabisaduhin. Bahalang malito kapag nagbigay na sa inyo ng mga decimal points and stuff like that. But as long as nandito po siya sa range na ito, you can consider it as a weak acid, moderate acid, or strong acid, as well as bases.